So our group have been looking at proxies of AMOC variability in the CMIP6 models. So main sort of achievements for the AMOC characterization, we've calculated monthly stream functions at monthly resolution for about 400 runs. We've begun some temporal and spatial characterization, various correlations at different latitudes, and we've extracted representative time series at several latitudes, including the 26.5 north, which is a rapid latitude. Sea surface height analysis, we've extracted from the same range of models sea level at tide gauge equivalent locations, or the closest points in the model to the tide gauges, closest sea level points. We've examined the coherence of the tide gauges along the western boundary of the Atlantic and identified a sort of a cluster of northerly tide gauges in the northeast US, which are quite coherent. And from that, we've derived a representative time series. Sea surface temperature analysis, we've been calculating global mean sea surface temperatures, and then we've been identifying key regions in the North Atlantic, in the subpolar gyre and Gulf Stream regions, which are key indicators of the possibly key indicators of the strength of the overturning, according to some papers. And from that, we've derived sea surface-based indices. I'm highlighting these things out as creed to consider them products which will be available to the community. And then in terms of actual scientific results, that's still in progress, but we've looked at the end of century AMOC versus sea surface temperature indices. We didn't quite manage to do the sea surface height component today, because I think most of our sea surface height people disappeared for various reasons. In terms of the AMOC characterization, we've looked at, this just shows 26 north, and it shows that generally 26 north is quite a good place to measure the overturning if you want to capture variability which is representative over a broad range of latitudes. So millions of pounds haven't been wasted on the rapid array, so good to know. In terms of the sea level proxies, here's just a plot really showing the clustered sort of coherent tide gauges for a range of models for one of the SSP, I think it's SSP 126. Not too much to say about that, but what we hope to do, which we didn't manage to achieve, is to plot the end of century, the sea level difference between the beginning of the period and the end of the period against the transport change. Wish we could find results that looked as neat as this, but at the moment I'm just plotting transport against transport, so haven't found a strong result yet. Made more progress on the sea surface temperature proxies. So the top panels here show the AMV or AMO index, Atlantic multi-decadal oscillation or variability, on the x-axis against, in the top row, sea surface temperature dipole between northerly latitudes and southerly latitudes, and this panel here, the middle row, this is based on the subpolar gyre. So,
3 minutes for it.
Oh, that's good, brilliant. Okay.